All right, so here's growth and decay stories, or a little quick review. We use this equation for growth, and we say A is the initial amount. See if you can hear. Can you hear the water polo team practice in the background? Their music. It's beautiful. We're going to write the rate as a decimal. Usually it's given as a percent, so you have to move the decimal 2 to the left. And then this is just time, how many months, hours, days, years, and so on. Now, this is considered a growth equation when you're adding. If we take the same equation and we subtract, so if we take the same equation and subtract, this is now a decay equation where something's decreasing. So the only difference here is one is growing and one is decaying, and now we're going to practice it, right, in terms of it. So let's say you invest $100 in an account that pays like 5% interest a year. After 6 years, how much is in the account? So to understand it, we like circle the numbers that matter to us. The equation that we're going to use is the growth one, the plus, and then we're going to plug in. So T is the years, so we're going to plug in 6 years. A is the initial amount, which is $100. The rate as a decimal, move the decimal back to, and it's 0.05. The exponent T, time, is 6, and then all you do is type that in for your answer. So I'll do that too. It's 100, parentheses, 1 plus 0.05 to the exponent, 6. So type all that in. Make sure you know how to use your calculator. And that's $134, right? Even if you round it. And 1 penny. So it's $134 and 1 penny, and you answered it. How about if you had a situation where it's decaying? So let's say, well, like, what kind of things depreciate? So let's say, I don't know, a car depreciates at a rate of 2.6%. And then let's say you had a $30,000 new car. After 5 years, how much is it worth? So you have a car that depreciates, that's almost spelled right? At a rate of 2.6%. You have a $30,000 new car. After 5 years, how much is it worth? So we're going to write down the decay equation, which is subtracting. And then we're going to plug in. So T is 5 years. A, the initial amount, is 30,000. Sometimes you're given years. So if you're given like 2012 to 2018, then all you have to do is subtract the years to get it. So that's no big deal. The rate as a decimal would be 0.026. That's what that, even though it is a decimal, it's a percent, you still got to move it 2 to the left. And then the exponent would be 5, and then you'd use your calculator and then calculate it. So again, it would be 30,000. 1 subtract 0.026 to the exponent 5, and then how much would that car be worth? And it says 26,000, even though it's blurry. It does say 26,297.59. There it is. All right, how about half-life? So half-life is the amount of time it takes for a substance to become half its size. So let's say the half-life is 6 years, and you start off with 10 milligrams of some substance, and you want to know after 100 years, how much is left? And then what would that equation look like? So this is a decay because something is becoming half its size. So this is the equation we start with. And then we need to understand the initial amount. That's simple. That's 10 in this case. The rate, half-life means half means the rate is 0.5, half. And then this is the tricky part. So we want to know how many after 100 years. And so, but half-life means every 6 years. So we have to divide by 6. This tells me that half-life gives me the denominator. So just remember that gives me the denominator. And then the numerator is going to be how much time there is. So in this case, it's 100. And then that's what you put in. Sometimes you're asked a question and you have to figure out like how many hours in a day or how many days are in a month or something like that. But I want you to remember that the half-life gives you the denominator, and then the numerator has to be the same unit. So if one was months and one was years, you have to make sure that they're the same unit when you put it in the equation, and then you put it in and calculate it. So we have 10, 1 subtract 0.5 to the exponent 6 over, 100 over 6. Oops. And then that's how much is left. Not much, 0.0003. So as we do half-life, the more years you have, it gets smaller and smaller and smaller. All right, so that gives you like an overview of what we're looking at. What else was I going to do? Oh, I was going to do, how about if it's continuously increasing? We're going to look at that. Or decreasing. So if something is continuously doing that, then we still have A, we still have E, but now that E is a number in your calculator, and it's about 2.7, but this is not a variable. So if you say $200 is continuously compounded, and this is the key word to know what formula to use. Compounded means how many times you compound the money and add it back into your account, calculate the interest, and add it back in. So if it's continuously compounded at a certain rate, and then for so many years, could you calculate it? So something that's continuous, this is what we're using. So the initial amount would be 200. E is in your calculator. And then the exponent would be the rate times the time. So this is what it would look like. So for 10 years, you would go $200 times E, and then in the exponent would be 4%, but you'd write 0.04 times 10. And then you'd calculate that. So with this calculator, you need to know where E is on your calculator. So you go 200 times E, and then in the exponent, you go 0.04 times 10. If you have an older, like TI-89, you have to make sure you put parentheses around it, or else it won't work. The newer ones, you don't have to do it, but you have to put parentheses around the exponent, and then you should get this answer, which is about $300. $298.36. That's continuously compounded. There is another one. One was like logistic, right? A logistic growth. So if you have something with logistic growth, make sure I have the equation right. It's a more realistic model of growth. Very few things grow infinitely. Eventually, the growth stops. So it grows, and then eventually it flattens out. And so because of that, a better model is this logistic growth model. And in calculus AB, we actually work with this a little bit. And in terms of the initial amount, there's a constant up here. The rate is negative because it's decreasing. X is a variable and so on. You would be given an equation. And an initial amount. And this would represent, so let's say we had a story. This would actually be the minimum amount there would be. So let's say it's, I don't know, cats. That you started with 1,200 and it's going to decrease to this amount. Or it could increase to that amount. It matters like what direction it goes. So let's say it increased. So let's say you start with 1,200 and the maximum that it could increase to is 4,000. So let's say you started with 1,200 cats in a town, or in whatever, in a county, and that the maximum amount that you could have in terms of like it being able, the population is up to 4,000. That's not just going to grow to infinity. That eventually, in terms of populations, there's a cap number that it would go up to in terms of food and predators and all that. It goes up to that number. So here's an equation that describes it. And then you'd be asked a question like, find like after, so let's say after like 10 days, like how many cats there are, starting at 1,200 at this rate, and that's the cap number. You would then need to know how to type that in your calculator and plug in 10 to figure it out. So I'm going to show you, this calculator is a little bit easier to do, so I'm going to do it like how I would type it into the older calculator. So what I would do is I would type in 4,000 divided by, is that 4,000? There's 4,000. The divide sign, parentheses, and I go 1 plus 1,200 E, make sure it's the E that's the number, not the letter, and then the exponent, so this one pops up as an exponent already, and then it's negative 0.02 times, what did I say, 10, and then close it, and then enter, or control enter, and it would tell you how much it is. So, what did I do wrong? 1 plus, did I type it in wrong? 1 plus, because it's going down, 1,200 down, 1 plus E to the, did I put the wrong negative? Anyway, that's how you would type it in. And if you did it correct, it would tell you how much, and you would start in terms of how much it is. So in this case, the growth would be like 4 cats. But know that this is a more powerful model for growth, where something is growing and then eventually it's not going to grow anymore. There's like a cap to it, so that it grows to a cap, and that's called a logistic growth model. Anyways, hopefully that wasn't too much confusing. Focus in terms of understanding the basic growth and decay models. Continuous means you use the letter E for the base, and then the logistic growth is something that I'm not going to focus as much on, but you should know about it in terms of a strong growth model that goes up to a number that doesn't keep growing infinitely. All right, Mr. G Math over and out. I hope that review helped.